We're going to start this last video for Module 5, Lesson 5, Mathematical Modeling with number 19. You just did one just like it over here in the last video. So one more to practice on, identify the error. Now you've seen a model done correctly. Now you know how this one should look. So go ahead and shut off your video. Work that one out. Circle the step that has the error in it. And then we'll check them in just a bit. Okay, as we look at this one, oh here, I didn't label it. So line 1, line 2, line 3, line 4. I just know this is how Alex does it. You have to tell him what line the error's in, so that's why I'm doing that. So here's our original problem. So obviously there can't be any mistakes there. So then we start distributing 8x minus 32, because a positive times a negative is negative, looking good. 5x, a negative 6 times x is negative 6x. A negative 6 times positive 2, negative 12. Perfect. So left side stayed the same. Uh-oh, I see the error right here. 5x minus 6x is not 11x. And when you use your vocabulary for that, you should say in line 2, when the student combined like terms, 5x minus 6x should be negative 1x, not positive 11x. The only way that could be a positive 11x is if that one was positive. Let's see if everything else looks good. So they brought the 8 over here. Minus 8 gives us 3x. Add 12, that gives us negative 20. Yep. Everything else looks good, so it's just in line 2 where the error was made. So how about we just rewrite line 1 and start from there. So 8x minus 32 equals, and I'm running out of room, aren't I? 5x minus 6x minus 12. Oh, gee, wow, I'm barely fitting that in. Okay, so the left side will stay the same, 8x minus 32, nothing to do there. But when we combine like terms, 5 minus 6 is negative 1x instead of positive 11x. And then we still have our negative 12. So if we move all x's to the left, add 1x, we get 9x minus 32 equals negative 12. And then we want anything without an x, move to the right. So we add 32, add 32. And remember, when the signs are different, we subtract. 32 minus 12 is 20, and we keep the sign of the larger plus. So we have 9x equals 20, which is going to make our answer 20 over 9. So now we have to write it in words. So let's see, what would be the best way to say that? So in line 2, when the student combined like terms, (5x minus 6x equals negative 1x, not 11x. So there, I tried to get it all in one sentence. So in line 2, when the student combined like terms, 5x minus 6x equals negative 1x, not 11x. So that's a pretty good description, I think. We got it all in one sentence. Okay, so on the next video, when we start lesson 6, we get to do some word problems. So our warm-ups are going to take a little bit longer now because some of the word problems, like this next one we're going to do, is an entire page. So we have lots of parts, but that's okay. We got it. Because this is the best thing to study for your test. First, do your topics. That's number 1. And then study this. That's number 2. You do those 2 things. Finish your topics in ALEKS. Study this practice test. Maybe print a blank one and do one all by yourself. That would be a great way to get ready for the test. Okay, so we are on the very last page of lesson 5 in module 5. Oh, word problems. So just 4 of them though, so not too many. Okay, so this is the one and only one I put on this paper that says percent increase. Remember what I said on the other side. The minute you see percent increase or percent decrease, you write the formula no over O. That's the percent increase and decrease formula. So it's the new price minus the old price over the old price. So you can write N equals new, and is this not a price? So how about new cost instead of new price? O equals old cost. And we just plug it into the formula and boom, work it out on our calculator. So let's see what it says here. And I didn't even read the beginning. The minute I saw those 2 words, boom, I knew to write that. So percent, find the percent increase or find the percent decrease. And that was from the formula we highlighted on the last page. And that's the only time you use this formula is when it says one of those 2, percent increase or find the percent decrease. And it does say round to the nearest 1/10 of a percent. So let's highlight that just to remind us. So we had 1900 in 1996, 2710 in 2011. So this is more recent. So that would be called the new cost. So that would be 2710 minus the old cost, 1900. And the last number you write here is always the number in the denominator. So the 2 should match. So new minus old over old. And one thing that I see students do wrong on this, and it's only one, but I see it quite often, is they're like, oh, Miss Norris told us we can just type it in the calculator exactly like we see it. Well, this one you can't. Because when you type it in the calculator, just like you see it, it would look like this. 2710 minus 1900 divided by 1900. Our calculator's really smart, probably smarter than most of us. And it knows that when you type this in, it knows that division comes before subtraction. It has the order of operations built into it. So guess what it's going to do first? And it's going to make this 1. So it's going to do 2710 minus 1. That's not what this problem is. This problem is subtract those and divide the answer by 1900. So there's 2 ways to get around it, and you can see which way you like better. In the upper level classes, they're going to teach you to put parentheses around any numerator or denominator that has multiple terms. And I like that, but students aren't very good at remembering parentheses. So the other thing you can do if you don't want to put parentheses in is hit enter. So either one, fine. You pick your poison, the one you like the best, and you use that. Same answer. It will do this first, whether you put parentheses on it or whether you hit enter after the first line. So whatever you think you'll remember. But that's why we can't just type it like we see it, because it's going to go right here and divide, and it's going to say, oh, 1900 divided by 1900 is 1. And it's going to give us the answer 2709, because 2710 minus 1. And you're going to see the answer is not 2709. So we have to be smarter than the calculator and go, oh, multiple items, if it's in the numerator or the denominator, get parentheses. So 2710 minus 1900, close your parentheses so your calculator knows to do parentheses first, then divided by 1900. Or some students even do it in one step. They do this, write the answer, and then they do that. That would be fine as well. And so this is, let's just write all the stuff we got here. 0.426315789. This is another error that I see, because this problem I teach in the class before this. And students will write 0.4%. No. This says nearest tenth of a percent. This problem is not a percent yet. To turn a decimal into a percent, you have to move the decimal place 2 places. Then you can round. So this should be 42.6%. But what students do is they round first and then turn it to a percent. No can do. Turn it to a percent by moving the decimal 2 places to the right, and tenths is 1 decimal place. 6 followed by a 3 says leave it 6. So this would be approximately 42.6%. And that's a really hard thing for students to remember. First, turn it to a percent by moving it 2 to the right, then round to 1 decimal place. Because it says nearest tenth of a percent, so it has to be a percent first before you can round it. And I'm trying to decide whether to let you guys try this one first yourself. It's a little bit tricky, but why don't you guys see if you can do it? So the original price of find the original price if the sale price is $46 after a 20% discount. And I'm going to guide you hopefully in the right direction. Don't do 46 times 20%. That's what 95% of students do. It's not 20% of the sale price, it's 20% of the original price. Okay, so contemplate that a little bit, see if you can figure out how to do it. I will tell you in my 081 class, this is the most missed problem on the test. And it's because the typical student, but do you see the word of? It's not 20% of 46, it's 20% of the original price was the discount. Okay, so just think about it. This is the sale price, this is the discount. And there's a couple ways you can do it, but I'll let you think about it, then come back after you've given it your best effort and we can check it. And I'll show you the 2 different ways to do it. Okay, so this is my take, how the easiest way I think it is. So if it's a 20% discount, do you guys agree we're paying 80% of the price? So to me, that's the number one easiest way. Oh, they had 20% off, so they're paying 80% of the price. So let's just write it in words because we like words first. 80% of the price is $46. So that to me is the easiest, but a lot of students say, oh, I don't even think to do that. 100% minus 20% is 80%, but it is the easiest way to do it. So 80% of the original price, I should say. 80% of the original price is $46. And that's the sale price. So you would do 0.08 of, it says find the original price. So let's just write over here, P equals original price, just so we know what P is when we find it. So 80% of the original price means equals $46. And then it's a one-step problem. P alone, divide both sides by 0.80, 0.80, and it really should be 0.80, but when I'm solving equations, I usually don't put it in, but when I write the answer, I do. Alex is pretty picky about that. It will keep telling you, don't forget the 0 in front. So 46 divided by 0.80, and remember, we're finding the original price. So it should be higher than $46. Sound good? $57.50. Don't write 0.5. So the original price is $57.5, which is $57.50. Original price. So to me, that way is so much easier because rarely can people write the equation that goes with this. So when teachers teach it for the first time, they go original price minus 20% of the original price is $46. Because that's how we do it in our head. We take the original price, we subtract the discount like we did on the last page, and we get the sale price. That equation for some reason is really confusing to students, but it leads to the one we have. So original price doesn't have a number in front, so we put a 1. Well, guess what 1 minus 0.20 is? 0.80. So then we go right back to this equation. So I think more students would remember this. But this gives us the same answer. 1 minus 0.2 is 0.80. Original times the original price equals 46. And then just like we did on that one, you divide both sides by 0.80. So that's how I taught it when I was in high school and I was teaching students to do it. But trying to be a little more intuitive like this, oh, it's a 20% discount. That means they paid 80% of the price because 100% minus 20 is 80. So 80% of the original price is 46. So to me, that's easier than remembering this formula. But this is kind of like the meal formula, except you're not adding the tip. You're subtracting it because it's the discount. But I just think it's easier to go, oh, if it's at 20%, we're paying 80. Okay, the last two problems are what we call mixture problems. And you don't cover mixture in the next class, but then you cover them in the 1-5 class. There might be some 126 classes that do it, but I do the distance, rate, and time problems. And the work problems, I don't have mixtures in my class, but all the teachers do a little different. So with mixture problems, there's a formula to remember. It's amount times percent equals the total. And I guess I just memorize it in my head. How much I'm using times the percent, that'll tell me how much it is. Okay. So how much of a 20% die? So right here, and we'll put 20% there. How much, that tells us to use an X, of a 20% die, 0.20. And we know this is going to give us, when we multiply these, 0.20x. And 50% die, so that means how much 20% and 50%. So I'm not going to put that in there yet because I want to go to the next line so you can see where this came from. To obtain 6 liters amount of a 40% solution. And this is the only tricky part on the whole problem, but it's something we've already talked about. So if you know the total, let's see, let's go ahead and put this here, 50. And it's called the total because it says to obtain, and this one's 40. And we have X here. So remember when we were doing that rope problem, the 18-foot rope, if the first piece was 5, the second piece was 18 minus 5. If the first piece was 10, the second piece was 18 minus 10. So if I know the total, one of the variables will always be X and the other one will be 6 minus X. So I know I need to produce 6 liters total. So if I call this first one X, and let's say X is 1, what are you going to do to get this one to make 6? 6 minus 1 to get 5. So think of that. Actually, I think the rope was 9 feet long. So think of that problem we did. We knew the total was 9. We called this piece X. And then we started plugging in numbers. What if that was 2? What did you do in your head? 9 minus 2. What if that was 6? What did you do in your head? 9 minus 6 to get the other piece. That's the same thing. If you know the total 6, if one of the pieces is X, the other one's always the total minus what you know. So if this is 2, 9 minus 2, that gives me 7. If this is 6, 9 minus 6 gives me the second piece is 3. So if this is 1, 6 minus 1 tells me I'd have 5 liters of this. So does that make sense? Hopefully. Because it's just like this problem with that new added formula in. So when you know the total, one piece is always X, the other piece is always the total minus X, just like we showed here. If X is 2, 9 minus 2, 7. If X is 6, 9 minus 6 gives me this 3. And then we do exactly what the formula says. So this one would be 0.50 times 6 minus X. So we did this times this and got that. We did this times this and got that. And then those two combined are going to give us this one, which is 0.40 times 6. And that's my equation. That's why I love mixture problems, because once you fill out the box, the equation is written, because you're mixing this solution and this solution to obtain, that's why we use the equal sign, this solution. So amount times percent gives us the total for each one, and then the first mix plus the second mix gives us what we're obtaining. So then I just take this vertical and turn it to horizontal. So 0.20x plus, and I should put my zeros in, 0.50 times 6 minus x equals 0.40 times 6. So that's the equation. So bit of a messy equation, but we did learn in lesson 3 how to get rid of decimals. Remember, this is 20 over 100, 50 over 100, 40 over 100. So I can multiply all the outside numbers by 100, which moves the decimal place 2 to the right. So times 100 moves this to 20. Times 100 moves this to 50. Times 100 moves this to be 40. So that was called multiplying by the LCM, and they all have an imaginary denominator of 100, 20 over 100, 50 over 100, 40 over 100. That's why we chose to multiply by 100. 100 moves decimal places 2 places. So then we get 20x plus 50 times 6 minus x. And remember how we never go inside parentheses with the multiplication. Same thing. And this turns into 40 times 6. So that's not a bad looking equation there. That one, a little bit scary looking. This one, piece of cake. Do a little distributing, combine like terms, solve for x. So this will be 20x plus 5 times 6 is 30, and add a 0, that would be 300, minus 50x. 4 times 6 is 24, and add a 0. So there we have it. Pretty little equation. 2 steps after you combine like terms. So first we must do that. So 20x minus 50x is negative 30x plus 300 equals 240. And then we subtract 300, and that gives us negative 30x. This is gone. 240 minus 300. One's positive, one's negative. So we subtract. 300 minus 240 is 60. Keep the sign of the larger. Negative 60, or plug it in your calculator. 240 minus 300. And then divide. Opposite of times negative 30 is divide by negative 30. Double negative before you do another step. And here's another thing. Ding! Get rid of those zeros. So 30 divided by 30 is 1x. 6 divided by 3 is 2. So now you have to understand, just like we learned on our past videos, every x in that problem now has a value of 2. 2, 2, 2, 2. Every x is now worth 2. So we have to look up and see what question they want. They want to know how much 20% die and how much 50% die. So I can see these are the 2 questions they want answered. How much is amount? So in place of that x, you put 2. And in place of this x, you put 2. And then you can go down here, and where am I going to write my answer? I guess over here. 20%. The 20% die is going to be 2. And remember, every word problem has to be labeled liters. I think L is liters, big capital L, right? And the 50% die solution, 6 minus 2 is 4. So the 50% die solution, we need 4 liters. And there are your 2 answers. Kind of a cool little problem, right? And they're all, you'll see, all the mixture problems are like that. I'm going to have you do this one next. Exactly the same. You're going to write amount times, instead of percent though, this mixture problem uses money. So you're going to write amount times dollar equal total. So it's always going to be a decimal place. Percent, 2 decimal places. Dollar and cents, 2 decimal places. So this varies with dollars or percent. So amount times dollars equal total, or amount times percent equals total. And it makes more sense on this one because if you're buying 20 pounds of peanuts worth $3 per pound, you're going to go 20 times 3, $60. So that makes sense. You go 20 times 3 equals 60. Doesn't make as much sense with the percentage problem, but with money problem it does. So I'm going to have you stop the video, read the problem, fill in. You can see here peanuts, cashews, mix. So over here, peanuts, cashews, and the mix. And then up here, you're going to write amount times, and since it's not percent, you write dollars equal the total. Same formula we used up above. So that'll get you started. Write your sentence here, and remember, you're mixing peanuts plus cashews to equal your mix. So that's going to be your equation there once you get it filled out. That's a lot of hints. I probably shouldn't have given you that many. But go ahead and shut off your video. And the best way to learn is practicing. You learn so much more by trying to do it on your own before you watch me. So make sure you try this one, okay? I'll see you back as soon as you're finished. Okay, so 20 pounds, that's the amount of peanuts. So we put 20 here for amount. There were $3 a pound. With cashews, do we know how much cashews? How many pounds of cashews? Nope, so that's going to be our X or our C or whatever. Cashews worth $5 a pound. In order to make a mix, we're $3.50 a pound. So this is another one you have to think. And when I'm teaching this in class, what I do is I tell students, okay, we got this big vat. We just added 20 pounds of peanuts and X pounds of cashews. So tell me, how many pounds do I have in that vat? That's how many pounds are now in the mix, or in a bag, or in a can, whatever you want to think. So the most typical wrong answer is students do 20x. That means 20 times x. No, it's 20 pounds plus x pounds. So my mixture is going to be x plus 20 or 20 plus x, either way you want to write it. It's the 20 pounds of peanuts plus the X pounds of cashews. So sometimes when I draw that picture, that helps students to like visualize. Can't be 20 times X. Because when you're weighing this, you're going to put in the 20 pounds, plus you're going to put in the X pounds. So it's going to be 20 plus X, or X plus 20. So now I'm almost done. I have these filled out. All I have to do is follow what the equation says. This times this is 60. This times this is 5x. And remember, it's the two parts that equal the mix, because you're adding the cashews plus the peanuts to make the mix. And that's why I love tables, because your equation is going to be written after this step. So this is going to be 350, and because that's a quantity, it needs to go in parentheses after the $3.50. But that vertical column now becomes my horizontal equation written in the same order. 60 plus 5x equals 350 times x plus 20. And since there's just one decimal in there and you get to use a calculator, I would probably not get rid of it. If you did, it's fine. You would multiply and you could take that 0 off. So you could multiply this by 10, this by 10, and this by 10. Or let's just keep one in and do it. When there's one, sometimes I'll leave it in. If there's more than one, never, because students make so many mistakes when they leave it in. But let's just see this one. I don't think it's going to be too ugly. So we have, I'm just going to change this to 5x plus 60 just because I like my x first. That's the proper order. And then that's $3.50 times x, which would be $3.50 x. And then 3.5 times 20, I think is 70, but let's just 3.50 times 20. Yep, 70. So going to have a tiny little decimal over there with the x's, but no big deal as long as you get a calculator. It's when students leave like 3 or 4 fractions in and try to do it with a fraction, 99.9% of the time they miss it. So instead of multiplying by an LCM, they thought they'd get real tricky and keep the fractions in. Rarely do they get it right. Just too many calculations. But this is one simple subtraction with the decimal. So nothing too big. So I need all my x's on the left. So I'm going to subtract 350x and put it on the other side. And that's 5 minus, whoops, not in the screen, $3.50, which is $1.50. So $1.50x plus 60 equals 70. So we're getting close, getting close. Subtract 60, and we have $1.50x, or times x, equals 10. Divide both sides by $1.50. And I always kind of like to look up at the table and see what it is I'm finding before I even type it in the calculator. Oh, I'm finding how many pounds of cashews are going to be in the mix. Because X is amount, and remember in this case amount was pounds, and that's another thing sometimes that I tell students to do just to remind themselves. Here amount was liters, and that just reminds you what your labels will be later. So this one was liters, this one is pounds. Okay, so 10 divided by $1.50 is going to give us, ooh, I don't like that at all. Well, do you guys see anywhere in this problem where it tells you to round? And it's not money. Money is always rounded to 2 decimal places. This is not money. This is pounds. It does not say round to the nearest pound. So what does that mean? And this is important for your next class. Exact answers are required. So I don't want to put that in. Alex won't take a repeating decimal. Remember how I said the 7's not really there, they round it. But your calculator will put it in a good format for you. So study those buttons. So this says fraction to decimal, but it's a double arrow. I'm going to put it over here. Oh, there, much better. Fraction to decimal, but see the double arrow? That means it'll also turn a decimal into a fraction. And then that way there's no rounding, because if you leave it as a decimal, you're going to be rounding, and it doesn't say that you can. So do second ABC, or excuse me, PRB, and then hit enter. And there's my exact answer, not rounded. So this will be 6 2/3 pounds. And I love that this one came out of fraction, because I can't tell you how many students would round on that, and then they'd get the answer wrong, whether a teacher's checking it or a computer. because if the problem does not ask you to round, you are not allowed to round. So you would say there are 6 2/3 pounds of cashews. So those are good learning experiences. Plus, when you're doing these problems in ALEKS, now you have great models with all kinds of notes written and explanations to help you solve them. And that's the last type you're going to see on ALEKS right there. So that is the official end of Module 5, Lesson 5. So 2 more lessons to go, and then we have our test. Okay, we'll see you back at Lesson 6.